All right, good morning, guys. Please excuse the rack. I don't know if it gets really blurry or like jumpy. I'm sorry. I'm trying to make do with what I have at home. Okay, so let's finish up our notes that we've been working on for forever. We need to complete number 10. So number 10 says that we have the function y equals cosine x, and we want to transform it. Okay, let me zoom in for you. Oh boy, sorry. Yeah, see, so just bear with me. Okay, so we want to transform it so that it looks like y equals 3 cosine 1/3 x minus 10 degrees. Okay, so this is our new function. Okay, and we want to describe the transformation in order. Okay, so when we are transforming and we're describing, so there's a particular order in which you have to do things, okay? And it works very similar to the order of operations like PEMDAS. So what we want to do is we want to work from the inside out, okay? But first, because this is in degrees, we need to basically factor out that 1/3 and rewrite this. All right, so because this is in degrees, we want to factor out this 1/3 and rewrite this. So if I factor out a 1/3, that becomes x minus, well, to get this into a 10, I would need to do 30 divided by 3. So this originally was 30. And I misspoke. It's not just because it's degrees. We basically do this when we are working with phase shifts as well. So this is a pretty normal situation to help us explain more explicitly what transformation is happening. Okay, so this is what we're looking at. So we know that this is our amplitude. Okay, we know that we do not have a vertical shift because there is nothing over here. Okay. And then right here, this is a horizontal stretch, okay? And then this is a horizontal shift to the right 30 degrees, okay? So again, I'll write out the order in just a second here, but we work it very similar to order of operations, so PEMDAS. So that means we're going to start at the innermost thing. So it asks for the order. So the very first thing that we're going to do is this horizontal shift to the right 30 degrees. Okay, so that is going to be called a translate. Okay, I'm going to zoom out a little bit for you, sorry. It is a translate 30 degrees in the positive x direction. Okay. All right, the next thing we need to account for, again, working from the inside out, next we need to account for this 1/3. And we talked about this, a little bit ago. We wrote about how a horizontal stretch or compression is actually 1 over this value. Okay, so because it is a 1 over 1/3, okay, off to the side, 1 over 1/3. If I keep, change, flip, that's really 1 times 3, or with a factor of 3. Okay, so our horizontal stretch, so this is a stretch horizontally because it's in there with the x, horizontally by a factor of 3. So again, that is true for every horizontal stretch or compression, is that it's 1 over that value. Okay, next we're going to go to this 3. So we call it our amplitude, but what it really is a vertical stretch. Okay, so then that is the final thing in this function, is a stretch vertically. Now, this factor remains the same. We don't flip it or anything like that. Okay, so this is a stretch vertically by a factor of 3 as well. Okay, so this will be our final answer here for number 10. Okay, let me see if I can maybe turn this light down so it's not so bright for you guys. Okay, so I'm gonna go ahead and list out the order for you here as like some general notes. All right, so your order of transformation. So add this to your notes. All right, so again, you work very similar to order of operations. So it's like the order, of operations. Okay. All right, so the first thing you want to do is you want to start inside the parentheses. Okay, which means you will look at the horizontal shift. That's left or right. Remember, it's opposite. And then the horizontal stretch or compression. Okay, and remember that is with a factor of 1 over that value. So that's why we did that 1 over 1/3, okay? And that's only true for your horizontal stretch or compression. All right, then the next thing you wanna do is if you have a vertical stretch or compression, so that's that amplitude, that number outside. And that factor is just the equivalent of that number. All right, next, if that number outside is negative, okay, that is a reflection over the x. Okay, and then the very final thing that you take care of is your vertical shift. Okay, so if you go up or down, so that's that midline. If there's something outside of the parenthesis, not the parentheses, but on the very end of your function. Okay, so that is it for the notes. All right, so now I have 4 practice problems to help you graph your trig transformations. And so I got some help from Miss Wraith, and so the way I'll be graphing is going to look a little bit different than we did in class because I found a much better, more like efficient, cohesive way to explain these things. Okay, so that's the end of your notes. All right, I'm gonna write down my 4 functions that I want you to graph. And then I'm gonna graph them, okay? So after I write them down, you pause the video so that you can write these 4 down. And then unpause to watch me graph and explain, okay? Oops, sorry. Again, bear with me. All right, 2 is y equals 2 sine 3x minus 1. 3 is y All right, so here are the 4 practice problems. That I want you to work, and I want you to have these ready for me on Monday. I'm gonna work all 4 of them with you. So pause it right here, write these 4 down, and then if you need to, watch the video of me graphing. So I know I have not restricted the domain on any of these, so the general rule is to graph. I want to restrict this one. This one's going to be on the interval from 0 to 2 pi. Okay, so on 1, 2, and 3, we're just going to graph 1 period. And then on this one, we're going to go from 0 to 2 pi. Okay. All right, so pause, write it down. Try on your own. Do what you can. If it's not working, then watch me. Okay, so here we go. All right, so number 1 is y equals 1/2 cosine 4x. So the first thing we want to do is we want to figure out what our amplitude is. Remember, this is like the borders. Okay, so my amplitude is 1/2. My midline or my vertical shift is out here, which is nothing. So that's going to just be the x-axis. All right, this 4 in front of my x affects my period. What I have to know is that the original cosine period is 2 pi. Okay, so I'm going to go period, and I'm going to say 2 pi divided by that coefficient of my x, 4, and I'm going to reduce that, and that's going to be my new period. So 2 divided by 4 is 1/2. So pi over 2 is my new period. Okay, so this means that from 0 to pi over 2 is 1 cycle, and then it will just repeat after that. All right, so what was really helpful that Miss Wraith showed me, so that if you took pre-calc with her, this is going to sound familiar, is that when I do my table, we were struggling with like, how do I know what to put on the x-axis? Well, a safe thing to do is to always do your period divided by 4 increments. All right, so to know your increments, you're going to do your period divided by 4, and that's going to be for sine, cosine, and tangent. All right, and so this is what I'm going to use to help me with my table. All right, so my period is pi over 2 divided by 4. Okay, keep, change, flip. Keep, change, flip. Okay, so my increments are going to be pi over 8, which means that I'm going to start at 0 in my table, and I'm going to add pi over 8, pi over 8, pi over 8, and I'm going to add pi over 8 until I get to pi over 2, okay, because that'll be the end of my cycle. All right, so I'm going to set up my table, x, y, okay, I'm going to start at 0, okay, and then I'm going to add pi over 8, so 0, and then plus pi over 8 is pi over 8. Pi over 8 plus pi over 8. Okay, so again, we're just adding. So we're going to add pi over 8 to that. So that's 2 pi over 8, which simplify 2 divided by 8 is 1 pi over 4. Then I'm going to add pi over 8 to that. Well, that's going to require me to get a common denominator. So I multiply that by 2, and now I have 2 pi plus 1 pi, which is 3 pi over 8. 3 pi over 8. Okay, now I'm going to add pi over 8 to that. Okay, common denominator, so it's 4 pi over 8, which is just pi over 2. Boom, that's what I wanted. That's my period. So from here to here is 1 period, and that's what I wanted. Okay, so we know we got to remember the shape of that cosine graph. Okay, so our original cosine graph, if you go back to the notes that we were just working on, okay, our original cosine graph starts up on the x-axis, on the y-axis, and then goes down and scoops back up. Okay, so if I plug in 0, okay, if you need your unit circle, get your unit circle. Okay, so cosine of 0 is 1. Okay, so 1/2 times 1 is going to be 1/2. All right, well then, so I know at the y-axis I'm up at positive 1/2. Well, then I know my original cosine graph is going to go down from there. So I'm going to go down, okay, half. All right, because that's my amplitude. All right, so remember, like if you need a little visual over here, like my midline is 0, I'm going to go up 1/2, and that's going to be my top border. Oh, come on. There it goes. And then I'm going to go down 1/2, and that's going to be my bottom border. So like if I'm starting here, and I know that the original cosine graph starts up and then goes down, like I know it's going to go down, and then back up, and then back up. Okay, so it's going to be a nice little pattern. So the first down spot that it's going to have, okay, so my period halfway between is going to be that midline. Okay, so my halfway point, let's not do that. Let's just do our pattern. Okay, because I know what my increments are. So I'm starting up here, a positive 1/2, then I'm going to go down to 0. Then I'm going to keep going down, and I go down to -1/2. Again, this is me using my amplitude right here and knowing the general shape of my cosine function. All right, then once I hit the bottom border, I'm going to come back up to 0 and then back up to a +1/2. All right, now I'll be able to graph. And again, I did not give you an interval because I just want you to graph the period. All right, so we're starting at 0, and then the first is pi/8, then pi/4. And then after this, like, it's just going to repeat. So like if you needed to go all the way to pi or all the way to 2 pi or whatever, like this cycle is just going to repeat